Hi, Algebra 2. This is Unit 5, and we're going to talk about sequences and series in this unit. The first lesson is going to talk about sequences. So what is a sequence? A sequence is a set of numbers with a particular order or pattern, and each number is called a term. So write that down. A set of numbers with a particular order or pattern, and each number is called a term. Now, there are two types of sequences. There's finite sequences and infinite sequences. So a finite sequence is a sequence with a limited number of terms. Like if I have the numbers 1, 2, 3, 4, 5, there's a limited number of terms. It ends. Starts with the 1, ends with the 5. And the pattern is I'm going up by 1 each time. An infinite sequence is a sequence with an unlimited terms. It's not ending. So maybe I have the set of counting numbers. The set of whole numbers start with 0, but the set of counting numbers start with 1, 2, 3, 4, 5. To show that it never ends, I do ... So sequence is just a set of numbers with a particular order or pattern. Each number in there is called a term. And I have finite sequences and infinite sequences. Finite has a limited number of terms and infinite has unlimited amounts of terms. Now I just want to go over some term notation with you. The first term in a sequence we call a sub 1, so an a with a 1 as a subscript. Each subsequent term is denoted with a sub n, where n is the term in the sequence. So the second term would be a sub 2, the third term in the sequence would be a sub 3. So if I'm given 1, 5, 9, 13, 17, okay, the pattern is, if you look at them, they're going up by 4 each time. All right, so I can continue this. After 17 plus 4 would be 21, plus 4 would be 25, plus 4 would be 29. And I'm just going to list a few more of these to help me answer the question down below. So a sub 1 is the first term. The first term is 1. A sub 4 is the fourth term. 1, 2, 3, 4. Well, that's 13. A sub 9 is the ninth term. 1, 2, 3, 4, 5, 6, 7, 8, 9. That's 33. All right, and a sub 12 is the 12th term. So that was 9, 10, 11, 12. Okay, so the subscript is seeing which term in the sequence it is. Sequences as functions. Since each term value is paired with exactly one term number, a sequence is a function with the following properties. The domain is the set of term numbers. And that's that top row there, 1, 2, 3, 4, 5. And a sub n, the range, is the set of the term value. Okay, so the first term had a value of 1, the second term had a value of 5, the third term had a value of 9, and so on. In an infinite set, the domain is the set of natural numbers or counting numbers. A lot of vocab right here in the beginning. All right, and then we have something called recursive formulas. So some of this should be familiar to you from back in algebra. A recursive formula is a rule in which one or more previous terms, a rule in which one or more previous terms are used to generate the next term. A rule in which one or more previous terms are used to generate the next term. A famous sequence is called the Fibonacci sequence. And it's 0, 1, 1, 2, 3, 5, 8, 13, 21, 34, ... In this sequence, the first term is 0, the second term is 1, and then each of the following terms is the previous term plus the previous term before that. So it's the previous term plus the term before that. So we know the first and the second term. The third term is the second term plus the first term. So 1 plus 0 is 1. The fourth term is the term before that, 1, plus the term before that. 1 plus 1 is 2. The next term is adding the two terms before it. 1 plus 2 is 3. The next term is adding the two terms before that. Okay, so that's a recursive formula. We're using one or more previous terms to generate the next term. So let's look at a sequence defined by the equation a sub n equals 2n minus 1. We're going to find the first three terms of this sequence, and we're going to call them a sub 1. So a sub 1 means I'm plugging in 1. 2 times 1 minus 1, and I'm plugging it into right here, 2n minus 1. 2 times 1 minus 1 is 1. That's the first term. Second term, I'm going to plug in 2. 2 times 2 minus 1 equals 3. And the third term, I'm going to plug in 3. 2 times 3 minus 1, which is 5. And you can see I am generating odd integers. That's the rule of what's going on. Which term has a value of 53? So I'm talking about my odd integers here. I don't want to list them all, but I'm basically trying to find out what term is this? What term has a value of 53? Just so you understand, this is not a of 53. I'm not plugging in 53 for x. This is saying what term has a value of 53. 53 is the answer. Right? So I'm taking that expression, 2n minus 1, and I'm setting it equal to 53. Solve for n, I add 1, divide by 2. The 27th term is equal to 53. Right? The 27th term is equal to 53. All right. Next page, some more practice because there's a lot to understand with all of this. I am determining a recursive definition in terms of f of n for the sequence shown below. Be sure to include a starting value. So we have to look for a pattern, like what's going on here. So 5 became 10, 10 became 20, 20 became 40, 40 became 80, 80 became 160. Basically, each term is 2 times the previous term. Some of these can get complicated, but this wasn't too bad. So they want me to write a definition, a recursive definition in terms of f of n. So f of n equals 2 times the previous term. All right, and is that all they want me to do? And I need to, whenever I write a recursive definition, I have to write the first term. The first term is 5. That's my starting term. They always need to give the first one. All right. A multiple choice for the recursively defined sequence. T sub n equals t sub n minus 1, meaning take the previous term and square it, plus 2. And the first term is equal to 2, and then they want me to find the value of the fourth term. So you have to go through these one by one. The first term is 2. The second term means take the first term and square it and add 2 to it. Well, the first term is 2. I'm squaring it and I'm adding 2. So 2 squared is 4 plus 2 is 6. All right, now I got the second term. The third term says take the second term, square it, and add 2. Well, the second term is 6. 6 squared plus 2 is 36 plus 2 is 38. And the fourth term says take the term before that, which is t sub 3, square it, and add 2. So I got 38 squared plus 2. That one I'll have to do in my calculator. 1,446. Okay, so that's it. The rule is each term is found by taking the previous term and squaring it and then adding 2. All right. We got 2 more examples right here. Find the algebraic formula a sub n, similar to that we did in exercise 1 for each of the following sequences. Recall that the domain that you map from will be the set 1, 2, 3, ... n. All right. So 4, 5, 6, 7. Well, the first term is 4. The second term is 5. The third term is 6. And the fourth term is 7th. So basically, the rule, all right, the formula is I'm doing n plus 3. Whatever the first term is, look, the first term is 4, the second term is 5, the third term is 6. I'm just adding 3 to that, whatever that term is. That's my answer. In B, the first term is 2, the second term is 4, the third term is 8, the fourth term is 16. All right. So this you might have to think about a little bit. These are my exponents. 2 to the 1 equals 2. 2 squared equals 4. 2 to the third equals 8. And 2 to the fourth equals 16. So the rule is a sub n equals 2 to the n. So the term is the exponent for 2 to the n. And in C, my first term is 5, my second term is 5 halves, my third term is 5 over 3, my fourth term is 5 over 4. So the rule is just 5 over n, because notice n is staying the same. This is really 5 over 1. So n, the term, is just the denominator. And last one that we have here, which of the following would represent the graph of the sequence a sub n equals 2n plus 1? If you look right here, which one am I looking at here? 1. All right, so this is 1, 3. That's that point right here is 1, 3. Some reason my pen's not writing. That point right there is 1, 3. This is going to be my, because I don't have the pen on. There we go. So this point right here is 1, 3. This point right here is 1, 2, 1, 2, 3, 4, 5 is 2, 5. All right, so I'm seeing what's going on. I'm multiplying the term by 2 and adding 1. The third term is 3, 7. I'm multiplying the term by 2 and adding 1. The next term is 4, 9. I'm multiplying the term by 2 and adding 1. All right. This one I don't want to, I'm not going to use 2 and I'm not going to use 4 because it's including decimals. All right. And remember, these are just terms. The domain is 1, 2, 3. Those are my terms. All right. And this one includes 0 right here. The first one includes 0. I don't want to include 0. So it is going to be choice 3. And we'll practice that tomorrow because I know some of this is new to some of you.